And finally, let me introduce our speaker today. So we are delighted to welcome Cara McWhirr, who's the Innovation Manager with Exodus Group. Cara is going to introduce us to carbon in context. So Cara, if you're ready, your 20 minutes starts now.
Thank you. As Hayley said, I'm Cara McWhirr. I have worked for Exodus Group for getting on for 15 years now. I am I'm a process engineer by background in field development, but really through my degree, electrical mechanical engineering. So that's one of the backgrounds for me for this carbon in context, is I've had to use context from what I was trained in and what I understood into different, as my career's developed, into different areas to understand. Sometimes I've had to ask those questions that you think everyone else knows the answer to. Should I be asking this stupid question? Exodus covers a wide range of energy industry, oil and gas, and also renewables as well. And our vision is that text in the middle layer, together we will deliver a responsible energy future, and that responsible thing is something I'll come back to a couple of times through this presentation. In true OGTC fashion, I'm going to do a couple of Menti polls. So you might want to, on your phone or the device you're watching this on, go to www.menti.com and I'll give you the code just so you don't peek at the question once we get to the right slide. It's just a dead easy way to do some quick polling and make it a little bit more interactive. So carbon in context. So this is all, what I want to do here is trying to put things into context of daily lives and context of oil and gas industry and how those two things come together. I'm going to use a few terms through this, so I thought I may as well just define them up front so everyone's clear what I'm talking about. So when I say carbon, I don't just mean carbon dioxide. That's it's a fairly common concept that we equate other greenhouse gases to the equivalent tonnage of carbon dioxide that would have the same effect, and usually terms CO2 equivalent and given a mass value. So whenever I say carbon, that's what I mean. I mean that total greenhouse gas effect. Energy transition, so that's the switch that's hopefully familiar to everyone. It's very much present just now, from switching from energy sources primarily from fossil fuels and carbon emitting sources to lower carbon fuel and energy sources. And then net zero, which we'll also mention, is a target that a number of nations have set to reach net zero carbon position. So if you are still emitting carbon, you're doing something that offsets that, so you're removing carbon from the overall system as well. And when we talk about carbon emissions, the source of those emissions and kind of how you account for them is commonly put into these three buckets: scope 1, scope 2, scope 3. Now, I regularly go back and look up what these definitions are, and I hear them sort of misapplied a lot. So just so it's clear, this is what I'm meaning when I say these emissions. So scope 1, that's anything that's direct greenhouse gas emissions from sources controlled or owned by a company. Scope 2 is electricity indirect greenhouse gas emissions, so from the electricity you're using if you're buying that in. And scope 3 is other indirect greenhouse gas emissions, and that includes from the products that you're producing. So burning gas that's produced from oil and gas facilities, as an example, is scope 3. So when we talk about carbon, do we know what we're talking about? The examples I'm going to put up here and on the next slide, I've pulled the numbers from this book, How Bad Are Bananas, which is I highly recommend having a look at. It's got Mike Berners-Lee, and it lays out carbon footprints for lots of things that you use or do in your everyday life. And the whole concept behind the book is to try and give some facts, and that's something that's quite often missing. And it highlights that you need to dig right through the supply chain of things to understand what their true carbon footprint is. So here are two what I think or thought were environmentally conscious decisions that I've made in my life, both of them for quite a long time, and just questioning them, are they sensible? So I only buy soft fruit in season, so strawberries, raspberries, those kind of things. I don't buy strawberries in January, partly because they're horrible and acidic and nasty, but also because I think that they're out of season, they're coming from far away, so there must be a bad impact from that. And similarly, I tend to buy wine from Europe, from Spain, Italy, France, rather than from much further away, from Australia, from New Zealand, from Chile, from these places. And both of these I've chosen to do because I think it's an easy choice. There's no real impact. I don't really miss having the berries. I'll have some different kind of fruit out of the summer season, and my palate is not it's not sophisticated enough to really tell the difference between a bottle of Italian wine and a bottle of New Zealand wine. So why not just pick something closer to home? If I dig into what the actual footprints of these numbers are from this book, in season, strawberries per punnet, you've got 150 grams of CO2 equivalent as the carbon footprint of that punnet. In the winter out of season, that's 1.8 kilos, so that's more than 10 times the impact. And that's because they're delicate, they have to be often air freighted. There's also a huge amount of waste because of damage. Something like a quarter of the carbon footprint is just due to growing and transporting things that then get thrown away. So I think that's a pretty sound decision. I'm quite happy with that. When it comes on to the wine, however, if I look at the carbon footprint of a bottle of French wine, it's about 1 kilo per bottle. And compare it with a bottle of New Zealand wine, it's about 1.5 kilos. Now that's not as big a difference as I expected. So they've got one bottle that's coming from quite close by and one that's coming from the other side of the world. But here there are reasons for that. There's CO2 produced by fermentation. That's just a fundamental fact of making wine. And the other thing is the transport from New Zealand is coming by boat generally, and from France it's coming by lorry, by road, and it's like your gut feeling on the difference between those, even though it's much further away, isn't that good. Another thing I've totally missed in this choice is that in both cases we're transporting a lot of glass a long way. And actually the better choice is to choose wine that's maybe bottled in the UK and that all that glass hasn't been transported, or it's come in a box or a carton or something like that. So this is a choice maybe I'm not so clever. So this is a test. If you can go to Menti and enter in the code 59344, I've put three things here to rank from highest carbon footprint to lowest carbon footprint. So I've got a litre of petrol, a pint of milk, and a banana. Which of those has the highest footprint as number 1, and the lowest footprint is number 2. And I will open the voting. There we go. So I'm hoping to see some votes come in. This is. Oh, I've got one. Someone's voted. They're coming in now. So I'll just let this run for a little while. So this is really just to test, like in our everyday lives, how good is our gut feel? You know, how good's that sense of smell almost to guide us in the right way. So I'm going to stop that now, and show the results. There we go. So first we said a litre of petrol. Second, a banana, and third, a pint of milk. So how good were we there with our gut feel choice? Back to the presentation. So here's a kind of scale, logarithmic scale of carbon footprint. So the best one. So we had the litre of petrol, right, as the highest. We had the banana as the second, and the pint of milk as the third. Actually, a pint of milk's about nearly 10 times the carbon footprint of a banana. And that's the whole reason that the book is called How Bad Is a Banana, is because people think bananas must have a high carbon footprint because they've come from far away. But actually they're grown using very little energy input just from the sun. They're transported by ship. They're easy to store. They've got a long life. So there's lots of reasons. They're actually quite a very good choice of a fruit if you're looking for a low carbon footprint. And it's only if you look at those facts and you challenge that and you dig in that you can understand and then make sensible choices. So on this scale, I've shown the carbon footprint of each of these things, and then to get a bit of an idea of how those numbers, which can be a bit meaningless sometimes, actually are visually as the blocks here. In the middle, we've got the carbon footprint of a barrel of oil equivalent. This is an average in the UK, and this is just of the production. And in fact, it's not all the carbon emissions of that production, if you consider the full supply chain, published by OGUK. So that average barrel, because this scale gets ridiculous, the blue box there is the same. I've switched the scale to this little red dot down here to then jump on up. So we've got the footprint of a return flight from Glasgow to Heathrow. The average footprint of a person in the world, so that's about 7 tonnes. And then the average carbon footprint over a year of a person in the UK, so that's about 15 tonnes. So that's a number to remember and bear in mind as we go through the next section. Just that average footprint of a person is in the UK is 15 tonnes. So we've got a second test. So we tried it on some more familiar things. The same Menti page. If we go to that and rate these 4 things, so I've got compression, 100 megawatts of gas turbine compression in a day. 100 tons of steel, so that's the fabrication of 100 tons of steel. A pipeline installation vessel transiting for a day, and 100 helicopter flights traveling 100 kilometers each way. So again, from highest carbon footprint to lowest footprint, how do those stack up? I'll jump to the next question and open the voting. So that should be open now. It's the same page basically as we were on before. So can you rank these things? How bad are installation vessels? How bad is power gen? How bad are helicopter flights? So we've just got some votes coming in now. And here what we're trying to get across is to make good decisions, you need to have a good understanding of the facts. A gut feel can be a very poor basis for decision making, but you also need to have some kind of a gut feel to guide you into what things you need to put more effort into looking at, kind of thing. So it's similar to cost estimating, if anyone's familiar with that in the oil and gas industry. There are certain things, the big things that you know are going to be the most expensive or the most uncertain are the things you focus on the most, or any kind of design as well. And then the things that you know are less material, you don't focus on as much. So if we don't have some kind of gut feel as to what to get after, we're not going to know where to put effort into to make a material impact, and where we could be putting effort into something that's doesn't really matter. So I'm going to close the voting now and show up the results. So what we reckon? So we think the biggest carbon footprint is 100 helicopter flights, 100 km each way, then the steel, then the compression, the 10 megawatts for a day, and then the pipeline installation vessel. So let's check put the slides back up. What our gut feel, how close to reality was that. So what we had as the highest carbon footprint was helicopter flights, is by far the lowest of those 4 things. And I think this is something I've seen a lot, that people know that in their heads, in their everyday life, that a big part of their carbon footprint is transport, is flying, it gets talked about a lot. But actually when you look at the footprint of an offshore installation, and I'll come to that in a minute, and you look at these 3 things, you look at all these in context, it's not as big by any means as any of the others. The power there is nothing compared to that 10 megawatts of gas compression that's running. So that's helpfully exactly the result I thought we might get. And hopefully that shows you that our gut feel collectively isn't that good, and maybe we need to find out more about the facts and test out a bit more. So what I'm going to put up here are just a couple of typical, this is full life cycle over 20 years, footprints of a couple of different types of facilities. It's a small unmanned wellhead platform. It's not tiny small, but a small platform. What I've included in here is emissions as well at a host facility that's doing the processing for all the power associated with that, etc. So you can see that the operating emissions are by far the largest part here. So that's power generation, which is the biggest single contributor, flaring and venting, fugitive emissions, those kind of things. Logistics, so vessel and helicopter movements, relatively a lot smaller. Embodied carbons, that's the carbon in all the materials due to the manufacture of those materials, is relatively small as well. And transport and installation of the facility when it was installed, and fabrication, even smaller still. And then if we had a full processing facility, we've got a similar breakdown, kind of scaling up the size and the power requirements, and everything comes up. And that's the sort of to scale version of what that total life cycle carbon footprint is. And so this is a kind of made up facility, but it's kind of indicative of the kind of range of numbers we get. We can get smaller than this, we can get bigger than this, depending on the type of platform. And just a bit of context, that 3.5 million tons of carbon, that's, if you're 15 tons per person, then that's a city the size of about 230,000 people, which is roughly the size of Aberdeen. So that platform in its life over 20 years is about the same footprint as the city of Aberdeen population over a year. Another thing I want to bring in is context in terms of whose eyes you're looking through, what's their point of view makes a big difference. So this is the same view as we had before. So fuel emissions are the biggest thing there. But if you look at from the point of view of the project that's building and delivering this, are they looking at those operating emissions, or are they more looking at the materials and the embodied carbon? Obviously, it's going to depend what they're given as a target. Or if you're maybe looking at a facility that's existing, it's brownfield, and you've electrified it, suddenly logistics become much more important, or things like direct carbon emissions, so carbon that's removed from the gas and then emitted. Or if you're looking at it from a outside view, this bottom bit is the facility. The green bit is the Scope 3 emissions. It's the carbon emitted from all the use of the products. So different perspectives give you a kind of different view. So the last couple of slides I've got up here are putting some other things into context around decarbonising oil and gas. And it's really just sharing some facts that maybe help guide things. So offshore power gen typically, and there will be a huge range on this, typically costs around £100 to £150 a megawatt hour to run the fuel, the servicing, the maintenance and all of this. And it will use about 0.25 million scuffs a day per megawatt of fuel gas. Offshore wind, actually similar cost, with the potential that that's maybe reducing. Power from shore, from cables, there's some sort of rule of thumb numbers of about £1,500 a kilometre for cables. And hydrogen, blue hydrogen, green hydrogen, so £2 roughly per kilo to produce it, and about £3 per kilo for green hydrogen. So blue hydrogen is hydrogen produced from natural gas, but where the carbon is captured and stored, and green hydrogen being hydrogen produced through electrolysis with hopefully the electricity provided from low carbon sources. Now, the thing that bugs me about this, as I've found as I've got more involved in this area, is that everyone uses different units: megawatts, kilograms, million scuffs. So the last thing I'll leave you with in terms of numbers is just some direct comparisons of the same amount of power provided by some different sources in the same units. So if you're talking fuel gas to supply this 5 megawatt GT, that's equivalent at that £100 a megawatt hour to about £12,000 a day to run. So you're using about 25 tonnes a day of fuel, and volume wise, that 1.25 million scuffs or 35,000 metres cubed a day of gas, which at atmospheric conditions, that's about a 33 metre cube size, if you get that in your head. And if that was supplied by green hydrogen, then it's a higher cost. It's pushing towards 3 times that. The volume needed is much higher because hydrogen is very low density with a lower mass rate. and if it's provided for offshore wind. So it just gives a sort of feel for the spread of costs here, and of what these things are. And then I just want to leave with a few questions. So if you're decarbonising offshore power, if you think about that in a net zero context, that last one with the big green blob, has there been any reduction in carbon emissions, or have we moved scope 1 emissions, so what's been burnt on the platform, into scope 3 because we've been able to export a bit more fuel gas so someone else is going to burn it? You individually, what's your biggest lever? Where can you make the biggest difference, at home or at work? If you compare that 15 tonnes of your annual footprint, how easily could you save that through efficiency savings and things like that in an oil and gas industry context? And then what's your out of season strawberry or your New Zealand wine? What's your good or your poor decision? Or what is something that you could change for no real cost to yourself, no real impact? But yeah, with the facts behind it to back it up. So I am done. So I think we're on to questions now.
We are. Thank you very much, Cara. That was really insightful, giving us a feel for, are we making the right choices and where we're spending our time for operational emissions. I've seen some questions come in through the chat, so I'll start there if that's okay with everybody. So we had one come in from David Wilkinson asking, why does a pipelay vessel use so much per day?
Just purely down to power. So it would very much depend on the type of vessel. You know, a bigger vessel is going to you need more energy to move it along, but it's purely down to the size of the engines and your fuel. So if you fuel it on a lower carbon fuel, then it's not going to have as big emissions.
Great, thank you for that. And then we have another one come in from James McCavery. Hopefully I've pronounced that right, James. Were the costs per energy source operational costs only, or did they include capital costs? So
the offshore GT is really operational costs from what I've seen of where these numbers have come from. It's not someone thinking, I'm going to put a new power gen unit out. So they're not really levelized costs. They're not really the same thing, but they're more what's out there operating now versus new. So the wind are levelized costs, so it includes the capital. Similar with the hydrogen.
Great, and then we've got one from Pedro asking, what's the data sources, I guess, for the costs there? I'm not sure. Where could I find it in order to reuse it?
So I've put on the, hopefully catch it in the recording after this when it's available. I've put some of the offshore wind. There's a link into where those come from. There are a number of places where you can find hydrogen costs from. There is quite a big spread. That £2 and £3 a kilo are nice round numbers, are easy to remember, rule of thumb kind of thing. Yeah, so they're out there in various sources. Right?
Great, thank you. And a question has come in from Anka. Are there any apps or tools we can use to measure consumption per person? So is there any good kind of recommendations you have for that, Cara?
I know there's one. There are a number of carbon footprinting apps out there. There's one that I saw through Crowdcube or Kickstarter that's got a lot of support, called PawPrint. I think that will be launched soon. So there are tools out there you can use, and more coming. There's clearly an appetite for people to get some facts.
Yeah, absolutely. And another one has come in from Amy asking, what sort of jobs would there be working with these types of gases?
So
what does the market look like?
As hydrogen, there's a lot of talk and there's a lot of investment going in just now into hydrogen hubs in different places. Hydrogen is potentially a really good way to decarbonise domestic heating, particularly, and some transport or there's kind of lots of uses for it, but it's got a really neat angle that it can progressively decarbonise domestic heating, because you can blend a bit into the gas and your boiler can cope with it. But it's I guess standard energy engineering, manufacturing, safety, a lot of the same jobs and skills are in the oil and gas industry at the moment. There might be some offshore, it might be more onshore. It's kind of still to pan out.
I think that's a really great point there, Cara, as well. You know, all of the jobs we need at the moment and we have at the moment to sustain our energy industry, we're very likely to continue to need very similar skills as we transition to a new energy and different type. So there's big opportunities there for everybody, for sure. There was a comment came in talking about World Wildlife Fund has a good personal footprint calculator for those who are interested in going online and kind of seeing their own footprints. We've had a question come in from Roy. So as part of the energy transition, do you think it's going to be more critical to price the total carbon cost of ownership to ensure that we understand the decisions being made, i.e. perhaps what we already do is just better?
So understanding pricing, one of the key things I think we maybe need to get better at or clearer in is what we're including when we price for carbon. So there's one uncertainty is what do you include as the price, but also how do you account for what are you accounting for, and those divisions between scope 1, scope 2, scope 3. A lot of companies will define their own thing as this is what we are accounting for, and one of the risks I think is that it becomes very unclear. It becomes really difficult to compare one thing with another thing because everyone's drawn those boundaries in a different place. So yeah, I think it is. I think you should be able to answer those questions as to where, what is the impact, where is it from, and what is the boundary, how have you defined that?
Excellent. And Vinny is interested in a question around the location of your wines. So maritime shipping in New Zealand versus transportation of wine from France caught his particular attention. The ships use heavy fuel oils and their emissions are quite significant. And the distance travelled is longer too. Any thoughts on that?
So it's just, I guess you could look at that book as a good starting point. It breaks it down a bit more. That footprint is the amount of that is transport is maybe smaller than you might think, because of the fermentation releases CO2 as well. And there are differences in getting your wine from Europe. So if you, a good place to look is around the Rhone, because a lot of wine out of the Rhone region is transported along the Rhone River in barges, and that's a much lower carbon way of transporting things than in lorries through from like more central France or from Italy or Spain or places like this.
Great, thank you. And then we have a question from Dean around how soon do you think we could see hydrogen transport being implemented within the oil and gas industry?
Within the oil and gas industry, so for vessels and I don't have any insight into that, but the hydrogen project in Aberdeen is looking to set up that network, certainly onshore, and it seems an obvious expansion to look at the big vessel logistics that come out of Aberdeen with that so close by.
Absolutely. I think we see hydrogen in the oil and gas industry, the opportunities going forward. There's a lot of kind of overlap in terms of skills, jobs, but also what might we use hydrogen for offshore as well as kind of transport and storage and some onwards kind of end uses onshore. So it's a really interesting area, I think, for sure. We have a comment that's come in from James. Do you think the discussion has moved on from saving energy and is now more about greening up energy sources, based on the assumption that the world energy consumption will continue to increase? There's a subsequent one, but I'll give you that one first.
So again, we have seen, certainly if I stick with the UK, we've seen a big impact of energy efficiency measures in the UK over the last decade or two. that obviously has a limit. Once everyone that can insulate their houses has insulated their houses, we've all changed our light bulbs. And these things have all had a big impact. So yeah, the next step has to be something different. It's not just efficiency. What I'm seeing in oil and gas is a big focus on efficiency. It always feels like we're a bit behind. There's still a lot of low-hanging fruit out there in oil and gas in terms of things like spinning reserve and oversized equipment and just operating a little bit more responsibly. You wouldn't sit running your car engine outside a school, you know, that's now totally socially unacceptable. So we're kind of doing the same thing sometimes offshore.
And the follow-up to that, you've maybe answered it there, but if there's anything you want to add on to this one is, do you think that reduction in consumption is still an important part of the energy transition / achieving net zero?
Yeah, so that kind of ties in a bit with that efficiency. It'll be very interesting to see what happens once we get out of this COVID travel restriction world that we're in just now. If that actually people reassess their need to travel, I don't know, but that's one way we could commute less and save a lot of energy that way.
I know your question around where can we have the biggest impact, home versus work, is something I'll be taking away and thinking more about for sure as well. There's a question coming from Javier. So Javier says, I have the perception that there is not a clear connection between what is important for society and the value the market gives to that. Do you think this is something to think about?
So this is a deep and complicated question, but that price for carbon will be set in some way at what people are prepared to pay. Would be the ultimate. If people aren't going to pay it, it can't keep higher and higher. So it's captured in there somewhere. I guess what we've got in society, though, are very different opinions. So it's always this kind of average view. That Mike Berners-Lee book does raise an interesting point about the knock-on effects in terms of potential deaths from global warming and what value. If you look at the predictions of what that could be, some different studies are out there, and you take the carbon price. And so in oil and gas, we're quite familiar with attaching it's not really attaching a monetary value to life, but we have to equate things somehow. So we do implied costs of averting a fatality and things like that. Doing the same thing, carbon prices around what they are now value human life at really very low levels. Like, so I'm pulling a number out of the top of my head by memory here, but I think it's around £1,400, which seems horribly low, but unless that concept gets across to the world as a whole,
Tricky one, that. Definitely a deep question there for sure. So, question coming from Michael around, do you know how companies are actively monitoring their office carbon footprint, and is there anything employees could do to play a part in lowering their company's footprint?
So companies above a certain size, which I don't know off the top of my head, but will have had to do a 4-yearly energy savings opportunity scheme ESOS audit, which is identifying energy schemes. If your environmental ISO as well will require you to do those sort of things. So there are those schemes out there. There's nothing to stop anyone going above and beyond that kind of thing.
Great, thank you. We've had a really active Q&A session, so thank you all very much for that. Perhaps I could use my facilitator prerogative and ask you a question of my own, if that's okay, Cara. So you've given us a number of areas where you've outlined the footprints and showed them in scale with other areas that we could be looking to address carbon within. So what would your opinion be on the kind of top 3 target areas for reduction in offshore operational emissions? And aside from that, are we looking in the right place, or should we be looking elsewhere?
So there's, if you rank them in terms of what's easy and would have a reasonable impact, there's lots of efficiency things that are out there. We could just operate a bit differently. There might be a bit of a knock-on impact to other things, but there is a big benefit to be had. What gets measured gets improved is a bit of a cliche, but we're not measuring very well a lot of emission sources. So that's another area that could do with targeting. But I guess I would challenge some if you look at that net zero, that wider view, if you're doing things brownfield offshore, it costs a load of money. It's a very expensive way to make an improvement potentially, versus to spend the same amount of money to make the same improvement in a different area or to offset. And I don't see that being thought about very much. It's a very limited, just I'll look at this one asset and its footprint, its scope 1 emissions, and see what I can do, but not really look wider and go, where can I get my best bang for the buck? Maybe it would be on a different asset that's easier, or maybe it would be onshore, or maybe it would be somewhere else.
Sure, that's an interesting insight. It's almost like a basin-wide approach in considering the UKCS as one, and better understanding where we can make a big difference.
Yeah.
That's great. So we haven't had any more questions come through. We've only got a couple minutes left anyway on the Q&A. So if there aren't any more questions from any of the attendees or any other panelists, I will wrap up this Tech 20 here. So Cara, thank you very much for joining us today and giving us a really insightful talk around carbon in context and helping us better understand our own footprints and the footprints of the industry generally. There's a QR code for everybody to scan. It takes you to the upcoming Tech 20 schedule. Our next Tech 20 will be next Friday at 11 AM. We'd ask you kindly to please complete the survey at the end of the webinar to give us your feedback, and remember to head over to LinkedIn to continue discussions with Cara. Thank you very much and have a great weekend, everybody.
Thank you.
Thank you.